try an example. So we're going to go through this example and we're going to apply our steps to make sure that we start correctly, we end correctly, and we answer correctly. So step 1 is to isolate. Now, you need to look at both of your equations and say, okay, do I have an equation that my x or my y is already solved for, or should I solve for one of them? So if you take a look at, we're going to name this equation 1. We're going to name this equation 2. So if we look at equation 1 right here, y is already solved for. So our step 1 is completed for us. Y equals x minus 5. This y is already isolated. All right? Now, step 2 is to replace. So what we want to do is we want to look at our isolated variable and we want to say, okay, y is equal to x minus 5. So everywhere I see a y in my second equation, I'm going to put x minus 5 instead. So I'm going to write, starting with my second equation, which is this one, I'm going to write it exactly like it is, except for when I get to this y right here, I know what y is equal to, so I don't have to put y because I know it's x minus 5. So I'm going to say 2x plus 3. Now in parentheses, because we're substituting it in, we're going to put x minus 5. Now, we write out the rest of our equation. That's going to equal a negative 5. Now, we have our equation replaced, and we are ready to move on to step 3. Now, in step 3, we want to solve. Solve for the variable, excuse me, solve for the variable that we have here, which is x. We want to solve for this x here. So step 3 is to solve. Now remember, there are 4 mini steps that we can use to help us solve. So the first step is to distribute. So my equation says 2x plus 3 in parentheses x minus 5 equals negative 5. So our first distribution step is going to be here with our 3x minus 5. This is what we're going to distribute. So when we distribute that, we're going to get 2x, 3 times x is 3x, and 3 times negative 5 is minus 15, equals to a negative 5. All right. Our next step in our mini solving steps is to combine. Now, when we combine like terms, they have to be on the exact same side. So our 2x and our 3x, they are the same term and they're on the same side. So we are going to combine these. So if we combine these, 2x plus 3x gives me 5x. Bring down your minus 15 and bring down your minus 5. All right, next step is to add your constants. Add or subtract your constants. So I have a constant here, which is negative 15, and I have a constant here, which is negative 5. Now, our ultimate goal is to get our coefficient and our variable on one side and our constants on the other side. So since this constant is here, we want to move it here. So add 15 to this side. Bring down the 5x. These two cancel each other out, and we get a positive 10. All right, so we're almost done here. And our very last step is to divide our coefficients. And if we divide our coefficients, we'll get divided by 5 and x is going to be equal to 2. So we get our final answer of x. We now know what x is equal to. But we're not quite done yet. For step 4 in our substitution method steps, we need to plug in. So choose any one of your equations. Now the easiest equation to choose is always going to be the one that you already isolated. So here we isolated y is equal to x minus 5. So this will be the easiest equation to use. You don't have to use this, but it is the easiest. So we're going to take and we're going to plug in the known variable. Alright, so we plug in our known variable. Our equation was y equals x minus 5. But again, we already know what x is equal to. So we're going to rewrite this as y equals, and x is going to be 2, and we have our minus 5. So ultimately, y equals negative 3. And our very last step is to write your final solution as a coordinate. So therefore, your solution is, your x is 2, your y is negative 3, 2, negative 3. And you're done.